Hey everybody. Okay, we'll get started. So, hey, I'm trying not to move around too much because the camera guy will get really annoyed. There we go, right. Hey everybody. My name's Martin Woodward. So, I already kind of told you my first lie of today's talk, so hopefully it's the last. When I submitted the talk, there were 65,000 Microsoft developers using Visual Studio Team Services inside of Microsoft. There are currently today 73,713, I think, was the last number I saw. So apologies for it was a few months ago when I submitted the talk, so hopefully it'll be okay. Right. My name is Martin Woodward. martinwoo@microsoft.com if you want to send me an email. If you want to send me some abuse on Twitter, feel free at Martin Woodward. If you want to complain when Visual Studio Team Services has a problem, please do tweet me or tweet at VSTS. And then visualstudio.com/DevOps is where I hang out on the internet. My job title sounds very fancy. Principal Group Program Manager DevOps. Let me try and break that down for you. So, Principal Group Program Manager basically means I delete a lot of email, is what I do. And then the DevOps part means I delete a lot of email with PowerShell. So, you know, it's a fancy job. It's great. I enjoy it. I work on Visual Studio Team Services. Who here uses Visual Studio Team Services? Awesome. Who uses Team Foundation Server? Cool. Fantastic. That's great. Well, I don't need to tell you what VSTS is then. It does a bunch of stuff, and you use it, and that's great. And I am on the team that helped build that and keep it running. Today we're going to talk about the journey we took going from on-premises Team Foundation Server to Visual Studio Team Services, and some of the things we learned along the way. When I joined Microsoft in November 2009, not long after, this org chart comic came out. It's actually drawn by a guy who now works at Google. And it felt very familiar to me, joining Microsoft from a startup, especially this panel. When I first joined the company, the divisions inside Microsoft were separate. And I, as a remote employee, I work from my house in Northern Ireland. And I, as a remote employee, not only could I not get access to the Windows source code, I couldn't even see demos of Windows 8 as it was being developed. You know, when they had conference calls where they were going to show a demo, they would disconnect all the remote people while they did the demo, and then they would bring it back up again. It was an interesting time, should we say. Me coming from a little startup into this was an experience. That's changed substantially in the time I've been working at Microsoft, I'm very glad to say. And that change was very much driven from the top down. Satya Nadella, who's the new CEO of Microsoft, he mandated that we should have one engineering system in the company and we should work as one company. And that's where we're at today. We have one engineering system that Microsoft are in, ran by the VSTS team, by my boss, a guy called Brian Harry. That system is based on Visual Studio Team Services, so exactly the same VSTS that you use at the office and you use on your phones and things is the same version of VSTS that we use to build products in Microsoft. Everything from VSTS itself. So VSTS is built and deployed to Azure using VSTS and release management. Azure is built using VSTS and deployed to Azure using VSTS, which is quite freaky. What's more strange is Windows is built using VSTS, which then Azure use a lot of to host, which they then deploy VSTS. It's Inception, basically. So it all gets very confusing. We do have a backup in case VSTS should ever go down. I think it involves, you know, a computer buried in a mountain somewhere in Nevada or something like that. But hopefully we'll keep everything up and running. So when we do have problems with the service, we are usually the first people to find out, and I'll explain why. And then we also get lots of shouty people inside Microsoft joining a conference call if things go wrong. Including from time to time, I've had Satya Nadella jump on a phone call, which certainly gets you, focuses the mind when Scott Guthrie and then Satya Nadella jump on the phone call to see what's happening and when it's going to get fixed. So yeah, it's all good fun. This is the growth chart. The last number I took was August, so 75,713. There you go, that's the number at the minute. Obviously, millions of people with real jobs trying to get work done, and then 75,000 engineers inside Microsoft. Notice this is active users, so the chart goes up and down at Thanksgiving and Christmas and things, when people aren't using VSTS for a week, but it's mostly growing. We are going to get to a point where that'll start to level out, I hope. We'll run out of engineers at some point inside the company, but at the minute, it just seems to keep on growing. And that's been, you look at the growth curve on that as well, that's been a huge thing for us to adapt to, just the internal usage. But if you hear people say, oh, I don't want to use VSTS because I don't know if it will take, we're too big for VSTS, I don't know if it will take the load, just point them to this graph. The slides will be downloaded. No, it won't. We have 75,713 people. We have 4,000 engineers inside Windows working on one Git repository hosted in VSTS. You'll be fine. Okay. As I mentioned, just after I joined the company, I joined as a program manager, delete an email, and the first thing I got sent on, bear in mind I come from a startup where I had to do everything. I had to do sales, I had to clean the toilets. You do everything in the startup. You do whatever needs to be done. And then we came from that into Microsoft, and the first thing I got sent on was a course that allowed me to approve the hologram that got burnt onto the DVD that my product was shipping in. And I'm like, whoa, this is blowing my mind. So we were going to shipping shrink-wrapped software that gets manufactured in Dublin and Puerto Rico and places like that, and then shipped all around the world. When you're shipping software that sits on disks, you develop a very strong mindset of avoiding failure. Mean time between failures is what you try and reduce, because it's very expensive if you have to bring a DVD back, shred them, and then reissue that DVD. That gets a very expensive operation. And when updates over the internet and things aren't as easy as well, it's very expensive to be able to fix customer software. And so the culture inside of Microsoft was very designed around avoiding these failures. And that ended up having a waterfall type model of software with big stabilization periods and things, which we'll dig into. We started work on the service in August 2010, and with all these things, technology isn't the hard part, okay? To get from running in an on-premise TFS instance and taking it and running it in Azure, I can't remember if it was 6 people, 9 months, or 9 people, 6 weeks, or one of those, typical estimates you do. It was just like that. It didn't take that long for us to get the software working in Azure, because it already ran on Windows. We just had to change a few things. The main thing we changed was actually storage. In on-premises, hard drives is the cost of a hard drive, and it doesn't matter what you store on it, whether it's a SQL database or a file, it costs the same because it's just a hard drive. In the cloud, relational storage is a lot more expensive than blob storage. And so we made some changes very early on. There's a layer in the code base which basically says, if I'm running in the cloud, then when I'm storing binaries, store them in Azure Blob Storage, whereas if I'm running on-prem, then store them in the same SQL database with the rest of the data. And the reason why we do that on-prem is because it makes it easier to take backups and have a consistent backup of all your data. But it's the same code base that ships in VSTS in the cloud is the same code that ships in TFS that we then put onto an ISO image and give to you every quarter or so. and we keep the same code base. We just have some if statements. And then there's a bunch of things along here, like milestones in our journey towards DevOps. Probably the one to call out is in June 2014 was when we started, when Satya came in and did the mandate around one engineering system. And I remember being in the Windows, getting flown into the Windows team at that time and that experience. And I've still got the grey hairs from it now to this day. I used to be really slim before this happened. Started comfort eating and lost all my hair. So never mind. But it was an interesting experience, but we got there. And then we recently, in June 2016, was when we started working on GVFS, Git Virtual File System, which is how we scale Git to work with repositories of gigabytes in size. The Windows team Git repository is 250 gigabytes. Linux is 0.6 gigabytes, which is the biggest kind of open source Git repository. And so we started work on that with the Windows team back in 2016, and then we recently released it as open source, and it's now back in the Git community. I will say, if you're looking at GVFS, then you're probably doing Git wrong. There's sometimes when you need to use GVFS, but they should be very, very rare. So hopefully you don't need it, but if you do, we can definitely scale up to huge Git repositories. We have the biggest and the busiest Git repositories in the universe sit on VSTS, so we can take your load. When we did this DevOps journey, we learned sort of 5 categories of habits, and this is kind of how I'm going to break it down for you today. Some of these links are a bit tenuous to fit it into my slide, but hopefully this will make sense. So this is kind of the habits that we've learned as we've been going through. And these are things I see other companies learning as they're adopting DevOps as well. So hopefully this will translate. We shall see. So first one is obvious. Be super customer focused. And that's easy to say. What does that actually mean in terms of culture within the company? It's not just, the customer is always right. It's being customer focused. So one of the things we definitely do is we're always listening to our customers. We've got like all the usual stuff like a user voice, a Stack Overflow, that sort of stuff. Yes, of course, you've got to have those. You've got to listen to people. One of the things we do, which is unusual, which we never really did, or we did very differently in the old days when we shipped on-premises software, is for I'm going to say most interesting or busiest VSTS accounts, we actually assign a champ to that company who are on the product group themselves. So these aren't, this is kind of a shortcut to all the Microsoft account things that you do today, where you have a salesperson who turns up when you've got an EA renewal, probably, and then you have like some support people you can go call who are excellent at getting us when they need to. The customer champ is somebody who lives on the engineering team who has direct contacts with certain key customer accounts. And they check in with them regularly, they see how things are going, they get feedback from them, but they're also responsible if things go wrong in their account. So we had some issues this week. Apologies if anyone was affected by those. It was in Western Europe in particular that was badly affected, so I'm glad I'm here. Please come and see me if you're affected by them. I'll try and get you a sticker or something like that. I know that doesn't make up for it, but there we go. When that happened, I actually picked up the phone, and one of these customers just picked up the phone and actually gave him a call and said, "Hey, by the way, we're seeing issues. You might get affected." And they were, "Oh, okay, thank you." They hadn't noticed yet. And then they were able to communicate inside of their company to their customer base. "Hey, by the way, there's a problem that's happening. This is where you go to get the latest news. We will tell you when the problem's resolved," and those sorts of things. So it allows us that two-way communication as well, which is great. I wish we could scale better to do that. So we have Twitter and the internet and the websites for that for everybody. But it's really good to be able to do that service when we can. And it just builds trust and builds empathy within the product group, within the engineering team. They know a customer who's being affected by this. They've got them on IM. They are speaking to them, and they know exactly how it ruined their day or how they delivered something and it made them a load more productive. And it really helps build the empathy within the team as to what customers need and stay connected with the team. Obviously, we have in-product feedback as well. You'll see that in a lot of Microsoft products. You know, if you ever get the, can I report a problem, please do. They're incredibly valuable to us. There's lots of really smart engineers sitting around looking at those memory dumps and stack traces, trying to diagnose things. We have lots of telemetry that comes up and looks at those problems. So if you have the option to report a problem, we appreciate everyone you can send us, so that's great. We talk a lot about what DevOps is. The key thing you'll notice about the definition of DevOps is it's the delivery of value to end users or customers. And this is how we think about DevOps. You are constantly thinking, how do I optimize delivering functionality into my customers' hands? And that's a very different way of thinking about functionality. It's not how do I ship this feature quickly? How do I get this feature into QA quickly? It's how do I get this functionality, this value, into customers' hands as quickly as possible. And that's what we're constantly trying to optimize for and make faster. The definition of done inside my team used to be it was potentially shippable. You know, when we started our Agile transformation, it can be potentially shipped in production. And that's very easy to say when you're in an Agile team. Oh yeah, this is potentially shippable. We actually have increased our definition of done now so that it's actually live. It's not done until it's live, running in production, collecting telemetry that then proves or disproves your hypothesis that you had, which caused you to build this in the first place. And that's a whole lot more involved and a whole lot more customer obsessed, because it's not potentially shippable. It's shipped. It's running. It's collecting data that allows you to verify if this was a good or a bad change yet. And then you know, did we make it better? Did we make it worse? And then if you made it better, great. How do we make it better again? And keep making it better and better and better. When we're collecting telemetry, we are getting lots and lots of data about how you're using the service, and we're trying to pull in as much telemetry as we can, making sure we're not pulling any PII in there, because otherwise we have to deal with GDPR and all those sorts of good letters. So yeah, we try and collect a lot of telemetry about how the service is being used. When we have problems with the service, one of the things we do is look to see what telemetry we could add into the product to allow us to diagnose this problem quicker in the future. So we're always adding to the telemetry. And if you look at the growth line there, what's it about now? Just coming up to 2 petabytes of telemetry a day we're ingesting into, we call it Custo inside of Microsoft, but it's Azure Application Insights Analytics is what you can use it as. So we just pull in lots and lots of data. And that's really good for being able to diagnose problems, being able to ask questions. If I did such and such, would that make it better in the future? And gives us huge, Azure Application Insights Analytics. I'll use the real name. We're great at naming things, aren't we? I'll use that name properly. It allows us to ask these sorts of questions of our data and then get back answers quickly. Sometimes we don't even need to build software to answer a hypothesis. We can look at our telemetry. However, we're very careful in what we measure, in what we track as KPIs. So we only try and measure what's important and ignore the noise and not have too much volume. So just to make it interesting, and again, this will be a slide that's in the slides you get to download, but these are the things we do measure, and importantly, some of the things we deliberately don't measure for reasons we'll talk about in a bit. So we measure, how happy people are with a feature, how much they're using it. We make features opt in. If people are then opting out of the feature, then it's no good. It doesn't work. If we've got new UI, we allow people to opt into it, and then we monitor how much opt-out we get. If there is a high percentage of opt-out, then that UI doesn't work. I don't care how clever it is. UI is like a joke. If you have to explain it, it's not working, okay? So if people opt out of UI, then it's not working. Think again, go back, repeat. Do UI that works. Give me the data that shows the opt-in rates are high and the opt-out rates are very low. That's how you know UI works. We measure satisfaction. We use like net promoter scores and things like that to standardize how we monitor satisfaction. We're very aggressive on looking at our time to build. How quickly can we build something? How quickly can we get it out testing? How quickly can we deploy it, get it in customers' hands? How quickly can we get data back from that thing we fixed and decide if it was good or not? It's no good building a feature that takes you 6 months to decide if it worked. You need to decide if it works within the sprint, because our definition of done says collecting telemetry in production that's telling you if it's better or worse. A bunch of things around life site health. The important thing to look at here is where we optimize how quickly can we fix something. How quickly can we detect there's a problem and how quickly can we fix it? Not how long do we go without a problem. And that's what we optimize for, is how quickly can we roll forwards? How quickly can we fix? However, we don't want problems. Problems are bad. We hate having problems that customers actually notice. So but when you have a live site that's global, you know, while it might have impacted the Western European region, we've got, you know, millions of users who aren't in Western Europe as well. And it's quite easy to maintain a high level of 9s on your service availability if you look at a global average. You don't care. If the site's not working for you, it's 100% not working, you know? So we monitor our SLAs per customer account to see how we're doing, and then we look at the outliers, who's having a particularly bad experience. And quite often we'll give them a call and say, hey, what's going on? How can we make this better? Some of the things we don't look at, okay? I hope nobody is measuring how many lines of code your developers are creating. That's not a good metric, okay? Hopefully we all know this in this audience. A negative line of code count is a great day, okay? We don't measure estimates, which is awesome. When I had a real job, I was constantly filling out timesheets. Now we don't measure how accurate your estimates were, because people just lie. I don't care how accurate your original estimate was. I want to know how much work is left to build a feature. That's all I care about. I don't care how good your estimates were. And then we don't look at individual team velocities at the big level. Within a team, you care about your velocity because you want to know how many features you should put into a sprint. But above the team, as managers, we don't care what they say their team velocity is. We care how much value is being delivered into production for the customers to use in the area that they're working in, and how many live site instances they have, how quickly they fix their live site instance. Those are the things we care about as a management team. I mentioned about focusing on customers. I did have an example of focusing on the outliers in my deck. Probably a better one is from a few weekends ago. We actually noticed that a particular customer was having very slow response times. And we started digging into why. And it turned out that there was a job running against their system, which was running with administration privileges. It was an API level job, so it wasn't our code. It was code they'd written against our REST APIs. And it was running with warnings disabled. And the reason it was slow was because it was deleting a bunch of data. I'm like, what's happening? So this customer, their customer champ, got brought into the call and got told, hey, there's a problem with such and such a customer. The customer champ said, who's running that problem job? This is the name of the person. Oh, yeah, I know that person. I won't say who it is because we're being recorded. But, yeah, I know such and such a person. They may or may not live in Houston, okay? So it's not Western Europe, obviously. They may or may not live in Houston. It's like 9:30 p.m. However, I've got their cell phone. I'll give them a call and see if they know there's a problem. Gives this person a call. And so, hey, are you doing something? Oh, yeah, we're doing a migration this weekend. Oh, okay. Do you know you're deleting all of your work items right now? So we spend the rest of the weekend restoring that customer's data. When you delete stuff, we don't actually delete it instantly. We mark it as deleting, and then we go in the back, because deleting is really expensive. And then we go back and we delete it actually, within a few hours. So we stopped that happening. We restored the customer's data, and then this admin had a job on Monday morning. So that was great. We still had a customer champ, so that was good. I can't promise that's going to happen every time, but that's the sort of thing that happens by focusing on outliers of performance. We also subscribe to build, measure, learn, lean development. So this is what I mean by hypothesis. Our stories are written as, because we believe that X is going to happen, to prove or disprove this, we're going to run this experiment, and then we learn from those experiments. So the stories themselves are written very much as a hypothesis, a question that we then want to answer. And we need to build the stuff to deliver that statement and answer the question, is it better or worse? When we do this, we're continuously integrating into our master branch. We're constantly doing this. And so we use a thing called feature flags to enable us to always be shipping from master. We're always shipping from master all the time. So feature flags enable us to integrate the code, but allow us to selectively enable and disable features. So lots of you here are VSTS users. You have those toggle switches on the side that allow you to switch on features or not. You are actually self-enabling a feature flag. Quite often, if you see a bit of UI pop up, that's because we've switched on a feature flag of code that's been in there for often several sprints. Interestingly, when we shipped Git in TFS 2013, the Git code was actually shipping in TFS 2012, update 4, just it was switched off behind a feature flag. If you knew the right feature flag, you can switch it on, So we were always shipping master all the time. We're not building up any integration debt. And then just to explain, a feature flag sounds fancy, sounds amazing. Woo! It's an if statement is all it is, okay? So you just create an if statement. If feature flag is on, then go do something. Then you go write the code that's in the if statement, basically. And now the feature flag is switchable. You can toggle it on or off. And we can make that toggle. We can enable it per user, per customer, per organization, but also you as an individual user or as an individual account can switch those feature flags on and off, depending on where we enable it in the levels. And then finally, when those feature flags are removed, we have logic again in our build process to make sure that we are deleting the if statements. Because otherwise you end up with thousands and thousands of code branches, and you can't tell which code's active and which code's not active. So we constantly are deleting old features once they are no longer being used by the code base. But that's how we stay on main. And they're great because it enables a dark launch. You've all seen Scott Guthrie and Brian Harry doing these demos where they say, and now it's available in production, which is great. Marketing love that because they can do a big launch, they can get in the press, and it's brilliant. However, it's awesome until it goes wrong, okay? One time, fairly recently, we were enabling a feature flag, and it worked fine, worked brilliant. It was on Scott Guthrie's account and Brian Harry's accounts. It was working fine. Their keynote demos had been rehearsed and rehearsed and rehearsed. All worked great. We switched the feature flag on globally as Scott Guthrie mentions the feature. And then Scott Guthrie walks over. Actually, I think it might have even been Donovan. I can't remember. Starts doing the demo. And the site goes, starts to slow down. Well, what happened? And turns out, for very, very, very complicated reasons, we ended up causing a cascade failure. Because when you switch a feature flag on and announce it, everybody starts to use it all of a sudden. And when we were seeing the amounts of load that were happening because of this, that's when it actually hit a particular issue that was fairly hard to track down, but we did it in the end. However, we broke the site for nearly a day, okay, during a keynote. That's not a good way of making friends with your boss. And so now what we tend to do is switch feature flags on at least 24 hours before an event So any bloggers here, any people big on Twitter here, a top tip for you, go use Azure the day before a big event like a build or something, or an Ignite, and just go play around in the portal, and you'll probably find new features there that haven't been announced yet because they're already enabled. But yeah, there you go. We need to have this production-first mindset. I've mentioned all the time about LSIs, live site instance calls. Basically, when something goes wrong, the phone rings. People get paged. This is how you make developers do things right and developers worry about ops, is by waking them out of bed when it goes wrong in production. Okay? Soon you'll find the quality of your code goes really high, the level of your testing goes high, and because you're getting people out of bed and getting them on the phone to fix things. When somebody is called onto the phone bridge, they have 5 minutes to get on the phone bridge during the working day, or 15 minutes outside of working hours. And and it's actually Satcher that calls you. We have a robot that dials you, and it's Satcher's voice. It's like, get out of bed, you've broken it. It's nicer than that. But yeah, customers are really important to us. I'm going to get the audio and play it sometime. It's really funny, but it's not good whenever you wake up to Satcher calling you. So it wakes you up. So then we do that, and we try and handle the incident as quickly as we can. The first step is to mitigate the problem for our customers, get our customers working again. But we need to do that in a way where we're capturing the reason why, so we can do root cause analysis. Why did this go wrong? And that's very important that we're able to do that. And then so we mitigate as quickly as we can, and then we do root cause analysis, and that can sometimes take a week even to really nail down exactly what happened. And then for large problems, like we had a problem on Tuesday to do with some regular expressions, which anyone who wants to hear the full story, if I get time, I'll maybe tell it, but otherwise come catch me afterwards, and I'll weep in a corner and tell you what happened. But when that happens, there'll be a big blog post about that one, because that was a bad one. It impacted a lot of people, but also there's some important lessons we learned from this, which we're going to share with everybody. And then finally, we create repair items. So we generate things that tell people how to fix this in the future. And we need to fix those repair items. We need to figure out how to not let this happen again. They go onto the top of a backlog. You're now going to be doing that the next thing before you do any features. We're also transparent, as I say. We blog about these things when they happen. We have the service site up there. We have Brian Harry's blog, which I'm sure you've all read. And we just believe in being completely transparent about what's happened. That wasn't hugely popular when we first started doing it, especially when we highlight areas in other teams where things went wrong. But customers don't care. It's Microsoft. So we have to be completely transparent about any problems that happened. The key when you're trying to optimize your times to report, your time to come back and fix issues, time to mitigation, is how quickly you can alert. But what you also have to look at is the quality of your alerting. If you have lots of alerts going off all the time, people ignore them. So you need to tune your alerting so you only get alerted when things are going wrong. And that requires constant adjustments. When we knew we'd achieved a certain milestone when we were able to, alerting. Yeah, we knew we were able to achieve a certain milestone when we were able to automate. So get Satcher to pick up the phone and dial you and tell you that the system isn't working now. That's done by the SRE bot. We have bots for everything nowadays. So it's AI that helps us do the alerts, and then a robot that picks up the phone and calls you into the bridge and gets you on the team. And it tries to get the person who is responsible for the area on the phone first. Here's a great lesson we learned. When we were first doing deployments, we used to have these scripts. Here's how you deploy it, and we would practice them. And most of the time it was all checked in, but sometimes there's one-off things that you have to do when you're deploying, so we'd write them down. We'd have a checklist. Checklists are awesome. They get sent around in email, they get put in OneNote. It's great. However, they can lead to some problems. So here's a quiz for you. What's the problem with this, other than it being PowerShell? What's the problem with this as a script? Smart quotes, okay? When you copy-paste these things between email and Outlook and Often you get these inserted in, and then all heck breaks loose. And then all of a sudden, you've got to fix a bunch of that stuff. It all goes wrong. People copy-pasting in between each other. You end up with problems that are happening. Once this kind of happened, we didn't spot it, and we managed to break production one day, and for a whole day, because our automation was partially automated. We had scripts that somebody manually ran. We don't manually run scripts in production now. We check in everything, and we run it in production by going through various rings, and we use VSTS release management to actually do that. So we check in PowerShell scripts sometimes, and then we deploy them across there, and that's how they get into production. Not only does that give you proper versioning, and also allows you to secure access really well, it stops stupid things like that happening. When we are going to production, we actually do it in five rings, so 5 levels. So the first ring is what's called Canary. So that's where our account lives. That's where the VSTS account lives. We then go to our smallest external data center, which we go to, and we start deploying it there. And then we go to our largest external data center. So the idea is you're looking at limits. So first of all, look at internal data, make sure we exercise it, make sure it works. Then we go to a small data center, make sure it works. Then we go to the biggest, make sure it still works. And then we go to our international data centers, start deploying there, because that's the highest latency from Redmond. And then finally, we do everywhere else. Okay, so that's the order in which we do things. And the idea being that you usually detect the problem very early on in that ring. Normally, if there's a problem, then it hits you in Canary first. We did have a problem on Tuesday that didn't come up until further on, and that turned out it was due to 2 things. One was the load patterns were different in these rings, so CPU utilization and memory utilization. And then also turned out what further complicated the problem is there was a time to live on the actual code. So it was to do with Azure Active Directory security token, which has a time to live of 12 hours. And so it didn't kick us until 12 hours after we'd done something. So there was this delayed problem as well, which was interesting and fun to try and track down. But the blog post will come out about that. So when you're doing this live site culture, it's important that live is what matters. Today, there's an issue that's dragging over because there's a problem with a CDN cache in Western Europe to do with NuGet. It's like really annoying, but we'll get it sorted. I missed a call with some very important people today because there was this production issue that 2 or 3 people had reported. Live site status has top priority over everything. Root cause of everything. It's no good just saying I switched the machine off and on again and now it's working. There's a dodgy CDN server somewhere. That doesn't matter. You don't care that there's a dodgy CDN server somewhere. You care that you ran a build once and you ran a build twice and didn't change any code and now you've got a broken build. Our build servers are not working for you. That's what matters. So we've got to figure out why. We've got to stop it never happening again. If we can't stop it ever happening again, we've got to make sure we can diagnose the problem quicker and fix it, ideally before customers notice. And then we also have what's called these DRIs, directly responsible individuals. On every feature team, there's a rotation of who is the DRI, who is the person who's on call, basically. And there's a primary and a backup of those. We also do a lot of security, DevSecOps, in part of our process. One of the things that we have is we do red teaming. I don't know if you heard it. So basically, we have an internal team of hackers that hack us all the time, and then we have an internal team of people trying to detect the hackers. It's great. Whenever I get an email that comes through, I assume it's my own internal team trying to hack me, and then I'm, very wary of all my emails as a result, because some of my friends are in the red team, so they particularly enjoy hacking me. The most worrying thing is the red team always get in, always. Now, these are people who have internal privileged insight into how the system works, but they're using ways of getting in and exploiting, sometimes to different levels, but their favorite trick is to log in as Buck Hodges, who's the engineering manager of VSTS. They always get in, when we do a red team exercise. We get better at detecting them, but they're always in. And then so we come in and we learn from that, and we put in new procedures in place to make it harder next time and make it harder and harder and harder. But you have to assume that somebody's in and then make sure you've got the systems in place to detect them quickly and figure out what happened quickly. So that's what we do all the time. The only way you get good at something is to do it over and over. The more painful something is, do it again until you get better at it, if it's important, okay? If it's like running into a wall, then don't do that all the time. But if it's important, then keep doing it until it's not painful again. Keep doing it until you get good at it. And we do the same with security. We went for an Agile transformation in the team, and Agile is very much allowing your teams to have autonomy and allowing them to develop the craft of software, because software, despite what people's managers might tell them, isn't just like civil engineering. It's a creative act you're doing. We're deliberately living on the edge of chaos, so we have to be agile. And one of the great drivers of our agile culture was this book called Drive by Dan Pink. There's a video on YouTube by RSA Animate if you want to get the 5-minute version of the book and save money. But it's a good book, read it. One of the things we give is we have some alignment. If we had 100% autonomy, it would be chaos. So we have alignment of parts of the process and then complete autonomy in other parts. Teams have complete control over what it is they do and how they do it and where they do it, actually. But we have autonomy into how we build our teams and how we structure them. So let's give you some examples. First of all, let me tell you what happens when you have too much autonomy. And this is one that's very close to home because I was involved with this. When we were going to bring in the Windows team, we asked them to come in on a 1-year migration. They were going to come in and they had this like big migration path. It was all a big plan. Then Satch and Terry Myerson got together and decided, no, we're going to go into VSTS. By the way, can we do that in 2 weeks? Okay. So when somebody tells you this, you say yes to a lot of things that you're going to regret later. So we said yes to a bunch of crazy questions that the Windows team had. Sure, do it. That'll be fine. And what we ended up with was a work item, a bug work item for the Windows team, which looked like this. This is how many fields were on it. Sorry, hang on a minute. This is what the fields look like. There we go. That's better. Okay. It was just crazy. So we don't do that. We try not to have too much autonomy. Within Windows, we've had to do a process to roll back that process debt now. And we have to, you're building up into process debt by doing that. So we fixed that. Our teams are structured. We used to have dev, test, and engineering. We brought test and engineering in together into one discipline. And then we bring ops, management, and engineering together into one feature team. And that's the team that are delivering into production, delivering value to the customers. They're responsible for the entire end feature. Our teams are in one room together. We do not do follow-the-sun development. We keep the team responsible for a feature together, and we change where we might give a team in India one feature, a team in North Carolina a different feature, and a team in Redmond another feature. We don't move it around because we believe it's important to keep teams together. We keep them together and we might change what they work on, but we keep the team together. Okay? When we do, we allow teams to change because we don't want the only way to be that you can move teams is by leaving VSTS or leaving Microsoft. So every 18 months, we run an exercise where we do sticky notes. I'll show you that in a sec, sorry. Our teams are always a very vertical team is what I'm trying to say here. So it's we make them own the whole feature. They don't just work on a data tier and then a framework or whatever. You have to own a feature for a customer. As I say, we do this sticky note exercise where people get to pick which team they work on. Teams self-select which team they go work on. I, as a manager, have to pitch why my team is important, and then engineers sign up to work for my team or not, based on what our charter is and what we're going to be delivering. Quite a frightening thing to go through as a manager, but it helps focus the mind and make sure what you're doing is important, and you can explain why. When we plan, we kind of know what we're going to be in 18 months. They're like bullet points, goals, where we want to be in 18 months. The main focus is 6 months out, is a 6-month season. We then have a 3-sprint plan that teams work on, and then we know what we're doing in the sprint. So as management, as senior leadership, they agree on kind of the end goals and look at where we're going to be in 6 months, and teams worry about all the rest. So as managers, I don't care that much about the 1 sprint and the 3 sprint plan. I care about where they're going to be in 6 months, what their experiences are going to be. And the benefits of this is obviously happy, smiley people sticking Post-it notes on whiteboards, but also the team's continuously planning, and we're constantly making sure we're getting better. And then I'm just going to whip through these 2 ones quickly, because this is where we're kind of improving now. So the first one is making sure we shift left, so making sure we do testing earlier in the process. So this is doing our unit testing, moving away from integration tests more into unit tests, which can run everywhere. It took us years to get this right, but you can see we gradually moved our test portfolio into integration testing rather than unit testing. Sorry, unit testing rather than integration testing. More repeatable tests, more reliable tests, got rid of all those unreliable tests. We also do more in the pull requests, pre-merge. We do a lot more as well. So we make sure that we do code reviews there, but we also, that's where we do build testing. That's where we do compliance testing, make sure any security testing as well happens in the pull request. And then you then merge that pull request in. So we have less CI build failures. We hardly ever CI build failure now, but we do get plenty of PR validation failures. And that's fine because the code isn't merged yet, so that's fine. And then finally, the thing that we're really learning is around treating infrastructure as a flexible resource. Taking this on-prem product and shipping it into 2 bits was very hard. The first thing we did was using the cloud for dev test labs. So going away from having hardware machines to having VMs in Azure. Then we had to split the code base in 2. And as we're doing this splitting of the code base in 2, we kind of pulled it into 2 big services, which we have split geo-locations, so we have that split across locales now. And then finally, what we're doing is starting to build new services as individual Dockerized microservices, which plug into one of these 2 monster services, is kind of how we have it structured. And it's a gradual process. We don't have the benefit of starting from scratch, otherwise everything would be Docker, probably. You know, we have a real job. We have software we have to keep going, just like you do. And so that's why we're doing it with containers. Containers, if we were going to do it only cloud, we would probably go PaaS. But containers allows us to build software that ships on-prem and in the cloud. So and also get all the benefits in terms of reduced cost. Right now, as I say, we have 3 main services out in containers, and we're doing more. And all Linux build hosts, they're actually containerized as well, in case you didn't realize. So that's why they're quite fast to spin up. Right, that was about what I had. Yeah, DevOps, just basically, you know, it's not all unicorns and rainbows. DevOps isn't somewhere you get to. DevOps is a journey of continuous improvement. It's not the silver bullet. You have to keep working on it. But we have come a long way from where we were by continuously getting better every sprint. And we keep trying to do that. So thank you very much. Our transition so far. And then the key takeaways, build, measure, learn. If it hurts, do it again and again and again. Treat the customers as individuals, not as just a big en masse, but look at individual customer experience. And allow the smart people you hire to own the problem. Don't micromanage. Let them tell you what to do. And always make it easy for the people in your team to work. Don't optimize to make your tooling cheaper or easier. Optimize to make your people more productive, and then you'll have success. Okay. Thank you very much for your time. Any questions, drop me an email or come on Twitter or grab me now, but thank you for having me.